Welcome back. Another video on anti-differentiation here. So this is looking at using rational powers, so negatives and fractions. Let's start with just some straight up differentiation of polynomials. So of course we will be adding 1 to our power and then dividing by our new power, giving us in this case 3x cubed over 3 minus x squared over 2 plus 7x. And of course we need our trusty plus c. Our 3's would cancel in this instance, so x to the power 3 minus x squared over 2 plus 7x plus c. We don't know what that constant is, we just leave our plus c at the end. Integration of x squared minus, what's that going to be, 8x plus 16 of dx, so expanding first. And that's going to become x cubed over 3 minus, so we get 8x squared over 2, which will just become 4x squared, plus 16x plus c. So we're pretty confident with that process. We're just going to use the exact same rule as you can see in our example 1, where we are adding 1 to our power and then dividing by our new power. I did write that with a positive indice, so moving our x to the power negative 3 to the denominator. Same thing for example 2. If we have a fractional power, we add 1 to our power, so a quarter plus 1 is 5 over 4. Divide by our new power, and if we're dividing by 5 over 4, that's the same as multiplying by 4 and dividing by 5, so we can neaten that up a little bit from there. Just noticed a quick problem with exercise 2, so plus c there. Always need that constant. So in question 1 here, you can see we're finding the integral of these derivatives to find our original function, and we are given a coordinate on each function so that we can find our constant of c. You can see I've made a slight change to my first equation, so 1 over x squared becomes x to the power negative 2. Then if we're adding 1 to our power, we get negative 1 there, and negative 1 here, plus c. I'll do y equals. We can neaten that up a little bit to negative 1 over x plus c. Subbing in our values of 1 and 1 gives us 1 plus 1, which is 2 for c. So our equation is 1 over x, negative 1 over x plus 2. That is our final original equation y. For question B, same kind of thing. So 3 times the square root of x, I'm going to rewrite that as 3x to the power a half, and I can start working away with that. So a half plus 1 gives us 3 over 2, all divided by 3 over 2. That's the same as timesing by 2 and dividing by 3. So we end up cancelling these 3's, and we'll get a 2 in our numerator. So 2x 3 over 2 plus c, and it's y equals. Subbing in our values, we would get 2 equals 2, 4. That's actually the same as the square root of 4 to the power 3. So just making it a little easier to work with the numbers. So 2 times 2 to the power 3. And that's going to give us 16. So we get negative 14 equals c, making our equation 2 x to the power 3 over 2 minus 14. We could also write this as 2 square root of x to the power 3 minus 14, I guess. So whatever you feel like there, but with negative powers, we generally like to turn them back into positive powers where possible. Question C was exactly as we had before. So here I'm just going to add 1 to both powers. So that's going to give me 7 over 4 divided by 7 over 4. And this will become adding 1, so a quarter divided by 1 over 4 plus c, and y equals. Let's just do a little bit of neatening up. So that's going to become 4x 7 over 4 over 7 plus 4x to a quarter plus c. Because we have x terms in each item here, so 0 equals 0 plus 0 plus c, we can obviously just say that c equals 0 when we sub in this point. So our final equation is simply what we had at this line here, We could do these with surds, but let's just leave it in this form. I think it's a bit easier to write out, at least at this stage. But you could change that if you wanted to use surds when subbing in values. So we've got a fairly challenging question from the textbook here, question 7. Find the equation of the curve which passes through the point -1, 2, and has the property that for each point xy on the curve, the gradient equals the square of the distance between the point and the y-axis. That is a pretty confusing question, but basically we're saying that this derivative function is just x squared. Y equals x squared, or dy of dx, I should say, equals x squared. I might even write that out here. Pretty tricky. That's probably the hardest part of this question, because once we get to that point, we can find the integral here, which is x to the power 3 over 3 plus c. And I can now sub in my value of 2, -1 to the power 3 over 3 plus c. 2 equals -1/3 plus c. So 2 and 1/3 equals c. We can then write our final equation, so x to the power 3 all over 3 plus 2 and 1/3. There's lots of different ways to write that, but I think that's a pretty neat way of working. So yeah, not actually too bad once we get into that question, but the initial setup is quite difficult. So do take your time in reading these questions and highlighting any key features if you get stuck.